Hi guys, I hope you are liking, subscribing, sharing, referring to your friends these videos, and I'm getting very good response from your end, as in like subscriber ends, and very good comments are coming up. So please do comment, and if you require any other videos, please just write in comment box. In this case, we am taking very important topic for multiple examinations and little complex topic. It is entropy change in adiabatic process. So how to solve about it? So basically, entropy change, which is represented by delta S, okay, so can be calculated on different account. One is called system, delta S surrounding, and delta S universe. So remember, if it is adiabatic process, by definition, by default, adiabatic processes are those processes where Q is 0. That means there is no heat exchange from surrounding. And since there is no heat exchange for surrounding, you can always say delta S surrounding is 0. So this you please take as a thumb rule, that delta S surrounding is definitely be 0, be it any type of adiabatic process. So be it a process of adiabatic where it is reversible, or it is irreversible, or it is free expansion. In all such cases, your answer for delta S surrounding will remain 0 without any confusion. Now, normally they will not ask only surrounding value, they will ask delta system also. So let us see how will you approach. Delta S system, as we know that ds system is we talk about this as a state function which comes as dq reversible upon t, and when we have cyclic integral on this, we get 0 on a closed loop, which is itself a proof that it is a state function. And any state function has a property that if you keep the end conditions same, let's say t1 t2 v1 v2 same, then your answers must match across. So when you talk about delta system, remember that delta system for this case can be written as integral dq upon t, but this dq itself is 0, so 0 upon t. If it is a reversible case, we can say this is 0, so all final answer will come as 0. So delta system will be 0 for reversible situation. So delta surrounding is 0 for all three cases, delta system is 0 for reversible. But if it is irreversible scenario, the same question comes in irreversible scenario. Now try to understand, reversible cases, the results that we use TV power gamma minus 1 is constant is not applicable for irreversible case. So try to understand, if I ask a same question with a T1 V1 value and T2 V2 is the final destination, so this T2 will not be T2 in irreversible, it will be some T2 prime. So what people get confused here is that my answer for reversible and irreversible delta system should be same, which is not true. Because in reversible case, the term dq upon t integral, which is actually cv dt upon t plus r dv upon v integral, which comes out 0 because these two terms are matching. But in this case, these two terms will not match. So we can say integral cv dt upon t plus integral r dv upon v will not be equal to 0. So we can't say this is equal to 0 for irreversible case. So how to proceed for this? We'll use delta S as cv ln t2 by t1 plus r ln v2 by v1. Okay, let's say for 1 mole, and if it is n moles, you will multiply these numbers by n. But remember, this t2 which is written here is not this t2, it is actually this t2 prime, which is coming up with another equation which is applicable in irreversible case. What is that? We say delta u is q plus w, it is applicable for irreversible also. Q is 0, so delta u is w, and delta u is ncv t2 minus t1 is equal to minus p external v2 minus v1, which is minus p external nr t2 upon p2 minus nr t1 upon p1 under ideal gas assumptions. So we will solve this mathematical equation to get our t2, okay, or we can say to get our t2 prime if you don't want to confuse with t2 and t2 prime. So this t2 prime is going to be calculated here, and in the calculation also I'm using this t2 prime word so that we can understand that the final temperature condition of a reversible adiabatic is not same as final temperature condition of irreversible adiabatic. Hence we can expect a different answer for irreversible system. So delta system for irreversible, if you solve, will not be 0, and delta system plus delta surrounding is equal to delta S universe. Delta surrounding is 0. Hence, my answer would be delta system itself will match with delta's universe. So which case I am talking about? This I am talking about irreversible case. And the same thing for reversible case. Reversible case में क्या होगा? Reversible case में आपका delta system भी 0 है, delta surrounding is also 0, delta's universe is also 0. So I hope irreversible system also understood. And the same question comes under free expansion. Free expansion. So remember free expansion, the work done is minus P external V2 minus V1, and this P external itself is 0. There is nothing against which we are doing expansion. So work done is 0. Q is 0 because it is adiabatic. Delta U is Q plus W, which is also 0. So we get all three quantities. Delta U is 0, Q is 0, W is 0. Based on that, we can conclude that NCV T2 minus T1 is 0. Hence, we can conclude that T1 is equal to T2. So in our final result, delta system, don't say it is 0, it will be NCV ln T2 upon T1, which is, both are same actually because there is no change in temperature, plus NR ln V2 upon V1. So your answers will be governed by, this whole thing is 0, only this part will come into the play and this part will only be considered. So your final answers will be based on NR ln V2 by V1. So I repeat the whole thing and we can put it in form of a table also. Reversible, irreversible, free expansion, delta S system, delta S surrounding, delta S universe. So I could say that for reversible 0, 0, 0. For irreversible, if you talk about delta system is, sorry, you can draw it. So surrounding is 0 in all three cases. System, if it is X, the same X is written here. If this is Y, the same Y is written here. And what is this X? X is nothing but NCV ln T2 prime upon T1 plus NR ln V2 upon V1. And what is this Y? It is NR ln V2 upon V1. I hope you can solve any question of this type and you will feel comfortable when you try to apply this. Keep liking, subscribing, sharing and commenting. Thank you very much.